So the next topic we are going to be talking about is arithmetic series. So 5-1 arithmetic series. So let's build off of what we already know about arithmetic sequences because these two things are pretty closely related. So let's look at the sequence that is represented in this diagram. I'm going to cross out these words stages just to be consistent with our language, and we'll call these terms, right? So the first term, the second term, and the third term. So here are some diagrams that are made out of sticks. So if we have terms and we have the number of sticks. And in our arithmetic sequence language, we would call the term numbers the positions, and the number of sticks is our values. So term 1 is made up of, it looks like 6 different sticks. Term 2 is made up of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sticks. So term 3, if this is really arithmetic, must have 14, right? Because our sequence in this case is going to be 6, 10, 14, and so it has to add 4. And the way you can see that in the pattern is, well, in the first one we have a complete triangle, so in the second one we have a complete triangle, and then we tack on these extra 4. So here is what term 2 looks like, and then in term 3 we add these 4 extra sticks. So that checks out. We've got an arithmetic sequence that's shown in this diagram. And so if we wanted to continue the pattern and say, well, that means in term 4 there must be 18, and in term 5 there must be 22. So a natural question that you might ask, so let's say Q1, a natural question you might ask is, what is the general formula? And so we're going to build off that arithmetic sequence formula that we've been using a lot of to figure out the answer. So our arithmetic sequence formula, u sub n equals u sub 1 plus n minus 1 in parentheses times our common difference d. And in this case, we know that our first term, u sub 1, is 6. N minus 1 we leave alone, right? N is our variable, and our common difference is 4, because we are adding 4 every time we go up one term. So there is our general formula. And you might also ask the question, well, now that we have a formula, we can figure out how many sticks are in term 10. And so that would be the same as asking, what is the value of u sub 10? So we can figure that out using our answer from question 1. So u sub 10 is equal to 6 plus, and now for n we're going to plug in 10 because we want to know specifically about the 10th term. And then our variable is already all by itself on the left side, so we'll evaluate everything on the right side. So 6 plus 9 times 4. We're going to multiply those two numbers together at the end, so 9 times 4 is 36, so we have 6 plus 36. And so our formula tells us that the 10th term, if you wanted to build the 10th term out of sticks, you would need a total of 42 sticks. 42 sticks. So far all of that was review. The new question that we can ask, though, if we're going to study arithmetic series, is how many sticks would it take to build the first 10 terms? In other words, I don't just want to use all the sticks from step 9 to build term 10. I want to lay them all out. I want to know in total, if I construct term 1, term 2, term 3, term 4, all the way up to term 10, how many sticks am I going to need? And so if we wanted to do this the low-tech way, basically we would want to take all of our terms in our arithmetic sequence. We want to add them together, right? We would need the 6 sticks to make the first one, plus the 10 in the second one, plus the 14, plus the 18, plus the 22, and you would keep going until you got to the 10th term. But the arithmetic series formula lets us add numbers much faster than that. So the quick answer to this question is use the arithmetic series formula. So we'll come back to this question once we have our arithmetic series formula. So as with all new topics, let's start out with our definitions. But in this case, we really only have one definition, and that is for arithmetic series. So an arithmetic series is the sum of the terms in an arithmetic sequence. So the key word here really is the sum, right? Anytime you need to add the terms of a sequence, you're talking about an arithmetic series. And like I hinted at, there are formulas that help us compute arithmetic series. So let's look at them because there are two different versions of this formula. So the arithmetic series formulas one version looks like this. So S sub n, it's a capital S, is equal to n over 2, parentheses 2 times u sub 1 plus n minus 1 times the common difference d. The second version also starts with that S sub n, because that S sub n is just standing in for the sum. It's equal to n over 2 parentheses u sub 1 plus u sub n. So parts of these formulas might look familiar to you. The variables represent the same things that they do in the arithmetic sequence formula. And you might actually notice this part right here, that is the arithmetic sequence formula. So it's embedded in this version of the series formula. But let's note down what our variables represent so that we can be clear. So in this case, n is the number of terms being summed. D is still the common difference. U sub 1, you may have guessed, is the value of the first term. And then u sub n is the value of the last term being summed. Okay. So let's see this formula in action. Let's see both versions of this formula in action with that pattern we were just looking at. So Q3, how many sticks would it take to build the first 10 terms? Let's look at our formulas. Oops. So we know that. Oops. Let's copy down our formula again. The first version, S sub n is equal to n over 2 times 2 times u sub 1 plus n minus 1 times d, all in parentheses. So in this case, we know that our first term is 4 because it takes 4 sticks. Nope, first term is 6 because it takes 6 sticks to build the first term. Our common difference was 4. And this question is really asking us about the first 10 terms. So what that tells us is n, first 10 terms, tells us that n is going to be equal to 10. So if we plug those numbers into this formula, we find that s sub 10, meaning the sum of the first 10 terms, is going to be equal to 10 divided by 2 times 2 times 6 plus, and here's our variable n again, so we're plugging in 10 minus 1. Our common difference was 4. And at this point, you can take that whole right side and plug it straight into a calculator. But if you want to see it evaluated, that would be 10 divided by 2, which is 5. 2 times 6 gives us 12 in the front, plus 9 times 4. So let's keep simplifying on the right side, marking inside our parentheses first, so we're following order of operations. We have 12 plus 36 in the parentheses. So 10 equals 5 times 48. And so it would take a total of 240 sticks. It would take a total of 240 sticks to build out all of the first 10 terms in this sequence. What's this work look like with the other version of the formula, though? So let's do this one problem both ways, just so we can illustrate that we get the same answer regardless. So the other version of this formula, s sub n is equal to n divided by 2 times the first term plus the last term. Oops. So s sub 10 is equal to, n still represents the same thing, right? So the n is 10 because we're adding up 10 terms. So it's going to be 10 over 2 times u sub 1, which was 6, plus, so in this case, we're going to be looking at u sub 10 because that's the last term that we want to add up. We're summing up 1 through 10, so 10 is the last term that we want to sum. And we figured out that u sub 10 in question 2 was 42. So for u sub 10, I can plug in 42 into the equation. So here I would get 5 times 48. Oh, and great. Get the same answer. S sub 10 is equal to 240 sticks. So you might be wondering, what is the big difference between these two versions of the formula, and how do I know which one I want to use? And that is entirely based on what information you are given or what information you can find out. So you'll notice that both of the formulas have the n over 2 at the beginning. The big difference between these two is that the second version of the formula relies on you having the value of the last term, whereas the first version of the formula relies on you knowing the common difference. So if I had asked you to find, let's say, how many sticks would it take to build the first 200 terms in the sequence, then you would probably want to use this version of the formula because you know the common difference and you know all the other pieces of information. But if I asked you to find the first 200 terms, or the sum of the first 200 terms, we don't right now know what u sub 200 is, so you could not plug it directly into this formula. Let's look at two other examples of using the arithmetic series formulas. So example 1. Let's say that we have a sequence. Consider the sequence 10, -8, -26, and -44, and so on. So those triple dots signify that this sequence will go on forever. but those are the first 4 terms in this sequence. And the question we want to answer is find the sum of the first, let's say 10 terms. No, let's switch it up. Let's do 17 terms. Find the sum of the first 17 terms. And so based on this information, you would see the word sum in the directions, and that should tell you immediately we're going to use one of the arithmetic series formulas. We just have to figure out which one to use. So remember, in the first version, if we know the common difference, we're probably going to want to use our first version. In the second version, we would want to use this one if we knew the value of the last term. So the question is asking us to find the value of the first 17, or the sum of the first 17 terms. Well, I don't know what the 17th term in this sequence is yet. I do, however, I can figure out relatively easily what the common difference is. So for this particular example, I would gravitate towards using the first example, or the first formula. So S sub n is equal to n over 2 times 2 times u sub 1 plus n minus 1 times the common difference. Okay, so 17, the first 17 terms tells us that n is equal to 17. The jump from 10 to negative 8 down to negative 26 looks like we're adding a negative 18, or we're adding a negative 18 each time. So that's our common difference. And our first term in the sequence is 10. And so we have everything that we need in order to plug into our formula. So S sub 17, the sum of the first 17 terms, is 17 divided by 2 times 2 times 10 plus 17 minus 1 times the common difference of negative 18. And again, make sure you put your common difference, that negative 18, in parentheses. And what I got was that S sub 17 is equal to negative 2,278. So the sum of the first term, so 10 plus a negative 8 plus a negative 26 plus a negative 44 and so on up to a 17 terms gives us negative 2,278. Let's look at a second example where we're only given the value of 2 terms in the sequence. So example 2, if we know that u sub 1 is equal to negative 5 and u sub 20, the 20th term, is 52, what is the value of the sum of the first 20 terms in this sequence? What is the value of the sum of the first 20 terms in this sequence? So if you hadn't already guessed, here's an example of a problem where you'll want to use the second version of this arithmetic series formula. And the thing that should tip you off is, one, again, that keyword sum. We want to add up all the terms. It tells us that this is an arithmetic series question. And then the real indicator that we should use, the second version of this formula, is that it asks us to find the sum of the first 20 terms, and it also gives us the value of the 20th term. So if we know the value of the last term that we want to add together, then we're going to want to use the second version of this formula. So let's copy it down. S sub n is equal to n over 2 times u sub 1 plus u sub n, where again, u sub n is that last term. So plugging it in, we have S sub 20, the sum of the first 20 terms, is equal to 20 divided by 2 times negative 5 plus 52. And when we plug the whole right side into the calculator, we find that the sum of the first 20 terms is 470. Our last topic with regards to arithmetic series is sigma notation. Sigma notation. So sigma is a Greek letter. The capital version of it looks like that. And it's used to denote sums that we can use to describe arithmetic series just in one succinct math expression. So you might see something that looks like this. Let's do an example. So, whoops. So there's an example of sigma notation that is used to describe an arithmetic series. So let's unpack it. What does this symbol mean and what do these numbers tell us? It tells us that we want to start at this value. So we want our variable n to start at 1. And we want it to go up to this value. So n is going to start at 1, it's going to go to 2, it's going to go to 3, and when it hits 4, we're going to use the 4 and then we're going to stop. And this equation, this is the rule that we are going to follow for each of those sums. So what this actually looks like is, well, we are going to let n equal 1 at the start. So that would look like 2 times 1, oops, 2 times 1 plus 1, because our rule is 2n plus 1, so I started out by plugging 1 into the formula. But this is a sigma, so it tells us that we are summing, so we're going to add to that 2 times 2 plus 1, and you should move all this over. So 2 times 2 plus 1 plus 2 times 3 plus 1, because our value for n is changing every time, plus 2 times 4 plus 1. And then we're going to stop when n equals 4, because our sigma tells us that n is going to start at 1 and it is going to go up to 4 and then stop. So n is 1, n is 2, n is 3, n is 4, and then we stop. So if we wanted to compute this sigma in our first block, 2 times 1 plus 2 is 3. When n equals 2, 2 times 2 plus 1 is 5. When n is 3, we've got 7 and then 9. So adding all those numbers up, 3 plus 5 is 8, plus 7 is 15, plus 9 is 24. And so this expression is equal to 24. So let's look at how that's related to arithmetic sequences and series. So consider the sequence. Start at -2 to 1 to 4 to 7 and so on. And make this an example. Let's say find or write the sum. Oops. Write the sum of the first 10 terms in sigma notation. So basically this question's asking, how can we take negative 2 plus 1, whoops, negative 2 plus 1 plus 4 plus 7 plus dot, 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 plus all the way up to the 10th term. How can we condense that expression into something that's more succinct using sigma notation? The first thing we're going to have to do is figure out what our rule is. And so that is actually a step that we've been practicing. So step 1, write the general formula. So in that case, that was u sub n is equal to, our first term is negative 2 plus n minus 1 times our common difference. It looks like our common difference is a plus 3, so d is 3. So step 1, write the general formula. Step 2, write the sigma notation. And once we have our general formula, we have everything that we need in order to write our sigma. So let's see, we'll draw a big sigma. And we want our variable, our n, to start at the first term. And we want it to sum up to the first 10 terms. So our value of n is going to start at 1. It's going to go up to 10. And the rule that we want this sequence to follow is negative 2 plus n minus 1 times 3. And so this is our answer. This is how you would write the sum of the first 10 terms of that sequence using sigma notation. So I'm going to write out a second example. Let's say we want to write the following sum in sigma notation. 3 plus 9 plus 15 plus 21 plus dot 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 plus 93. We want to write the following sum in sigma notation. Okay, so let's look. This tells us that u sub 1, our first term, is 3. And every time we increase, we are adding 6. So our common difference d must equal 6. So in this case, step 1, write the general formula again. We have u sub 1 and we have d, so we have all the information we need. U sub n is equal to 3 plus n minus 1 times 6. All right, step 2 says write in sigma notation. So step 2. Write in sigma notation. So draw your sigma. Our variable n is going to start at 1 because we always start summing from the first term. Oh, but wait. I know that I want to end with the value 93, but I don't know which position that 93 holds. Like, I know this is the first term, the second term, the third term, the fourth term, but how many terms in the sequence do I have to go out before I encounter that 93? I don't know that yet, and I need to find it because that's the number that is going to go on top of sigma. So we're going to have to do a little bit of scratch work on the side and figure that out. So what we're given is we're given u sub n. So we're given u sub n, and what we need to find is n. Where in the sequence does this number happen? So using the arithmetic sequence formula, let's plug in 93 for u sub n. And now we have an equation that will allow us to solve for n. So that gives us 90 is equal to n minus 1 times 6. And then if we divide 6 on both sides, we get that 15 is equal to n minus 1. So adding 1 to both sides, we find that n is equal to 16. So that tells us that this is the 16th term in the sequence, and so we would want n to range from n equals 1 up to 16. We want to add together the first 16 terms, and there's our rule.